Again, I'd like to welcome everyone to today's MSDN webcast, in-depth answers to your questions about Windows Communication Foundation. It's my pleasure to introduce today's presenter. We have William Steele with us today. William is a developer community champion with the Microsoft Corporation. And without any further delay, I'm going to turn the floor over to William.
Thank you, Tracy. Well, hello everybody, and welcome to today's webcast. This is a webcast about WCF, or Windows Communication Foundation. And basically, it's we've been doing a live MSDN events series here in the States, and we've had a few questions that have come up while we've been doing this. So I put together this webcast to basically cover what we covered in the live event, as well as some of those additional questions that have popped up throughout that presentation. So to begin, we're going to be talking about the .NET Framework 3.0, which was formerly known as WinFX. And then we'll also talk about, drill into Windows Communication Foundation and talk about four basic areas: service orientation, services, transports, and then finally we'll wrap it up with a little bit of performance discussions. Their prerequisites for this session are actually pretty light. Just a basic understanding of web services will help you understand what it is that we're going to be covering, because WCF exposes its services through a very similar model to web services. And then some basic knowledge of .NET programming concepts will help you along as well. This is a level 200 course, and we will be covering a little bit of demo in here. So you'll be able to follow along with that. So let's start off by talking about the .NET Framework 3.0, formerly known as WinFX. The .NET Framework 3.0 is basically the set of core functionality that's built into Windows Vista and will be available as well with Windows XP, SP2, as well as Windows Server 2003. Now what it is basically it's the future of managed code at Microsoft. It doesn't replace the existing .NET framework, but it rather extends it for next generation scenarios and applications. It includes bits for doing things like user interface stuff. So Windows Presentation Foundation is the area where we will be dealing with next generation user experiences, where we deal with XAML to define what an application will look like and how it will render. We also have another section out here called Windows Workflow, and if you attend one of the MSDN events coming up in this quarter, we actually have a session on Windows Workflow. So if you're interested in attending one of our live events, msdnevents.com, you can actually go out there, and this quarter through the end of December, you'll be able to learn about Windows Workflow. The other section that we're going to be covering in the future is InfoCard. InfoCard is the portion of the .NET framework that allows us to handle digital identities. So you'll be able to integrate your own digital identity management system into your own applications through the InfoCard namespace. But today is all about Windows Communication Foundation. And Windows Communication Foundation is basically the bits that we're going to be dealing with when we're talking about connecting applications together. Windows Communication Foundation was formerly known as Indigo, and it includes a set of APIs, if you will, that allow us to communicate with other machines through what we call a services-oriented architecture or services-oriented development. So let's talk, to begin with, let's start off by talking about services-oriented development here. Now, services-oriented development is basically just a way of saying, hey, I want to talk to another computer, but I don't want to be concerned about the intricacies of the protocols that we're using or the network that we're running on. All I'm interested in is the messages that we're dealing with. SO is purely about the messages. SOA is not necessary for Windows Communication Foundation. They can easily be written without services orientation in mind. However, WCF is our framework for building services-oriented applications. Now, just like I said, it's about the messages rather than their runtimes. So in other words, we don't care what the technologies exist on either end of the connection, so long as that they both agree on how they're going to communicate. And this is what we mean when we say it's loosely coupled. So we're not concerned about the plumbing. We're only concerned about, hey, this is the message I'm going to send you, and you agree that this is the message type that you want to receive. Now, service orientation is not a replacement for object orientation. Just because they have the word orientation doesn't mean that they are the same analogy. They map to the same things. For example, service orientation simply means that I will be exposing my applications as services. Object orientation describes how I'm actually going to construct my application. Now, I can quite easily build an object-oriented application that is a service-oriented architecture. Now, another thing that a lot of people get confused on is that when we say service-oriented architecture, we do not necessarily mean web services. Web services are simply an implementation of a service-oriented architecture. It just happens to be the one that was the easiest to implement out of the box. You could just as easily build service-oriented architectures around other transports like message queuing or even SMTP services. I mean, there's been applications written that allow you to play chess, for example, through your email, and that's really a services-oriented architecture. And in that case, we're not using any web services to play that chess game. There are 4 tenets of services orientation. The first one is boundaries are explicit. What that means is that SOA concerns itself with what happens outside of the runtime. It only cares about the message being passed over the wire, and what lies outside of that is pretty much none of our concern. Services are autonomous. What that means is a service basically, a service should be autonomous, meaning that if a service has a dependence on another service and that service happens to go down for whatever reason, it shouldn't affect the first service. This is one of the most ambitious goals of service orientation, and in many cases it can actually be ignored when the architecture actually requires that. Services share schema and contracts. So instead of sharing runtime binary info, schemas and contracts are what's actually shared. A schema defines what data structures are actually shared, and the contracts define how that data is going to be shared. So when I go and interrogate a web service for the very first time, I know of a certain way of doing that. Typically, you would add the question mark WSDL to the end of the URL for the web service that you're getting. And what it's going to give you back is it's going to give you the schema and the contract that's required to actually call that web service. That right there is it's publicly exposed to me, and it allows me to then understand how I should be calling that web service. Well, services in an SOA are all done that way. And you'll see that in just a little bit here when I go into the second set of demos where you'll see how we actually describe through schemas and contracts how one should actually communicate with a particular service. The last tenet is compatibility is based on policies. And policy allows us to enforce rules. For example, security might be a prerequisite for a type of service that you're going to be calling. So we can use a policy to enforce that and allow us to enforce that we are going to have whatever policy enforced before we actually make the calls, so that you have your requirements ahead of time. So now that we talked about SOA, let's talk about WCF and what actually it is. WCF brings together formally disparate communications APIs. For example, remoting, web services, sockets, etc. All of those, it brings them all together under a single API. In the past, we had different APIs for the different types of technologies. So if we were doing web services, for example, we would use the standard web services mechanisms. But if we were using TCP, we'd have to drop down to socket level communications. And if we were using MSMQ, we had our own system.messaging namespace to deal with just the queuing of messages. But they all, in reality, are doing the exact same thing. They're sending messages from one machine to another or from one process to another. So what WCF does is it unifies that into a single API. We only have one API that we're using regardless of what the transport protocol we are going to be using over that. So it makes it really easy to work with this. In addition, it actually allows us to support both binary as well as text communications. Text is great for cross-platform interoperability. You know, you're going to cross a wire to a machine, you have no idea what it is. A binary is good for performance, but it does have a downside in that it requires, you know, a WCF at the other end as well. So both, you're going to have WCF to WCF communications. Now you could, if you were a third party, release a system that would allow applications running on systems without WCF to accept WCF binary messages. But it isn't really something that you can count on. So binary is typically going to restrict you to applications that are running exclusively on .NET. Now the benefit to that is performance, because you don't have to process the messages as much as you would text-based messages. You can literally start talking about the objects and sending the objects across the wire. So what's so great about it? Well, if we take a look at this graphic here, this basically describes the old way of exposing components through a web service or ASMX file. Here at the top we have our .NET component that we're going to be exposing. And what we do is we simply create a facade for the ASMX web service to actually expose that to our clients. And then our clients can then call into that using the standard web services interoperability standards to actually communicate with our web service. And that actually works great if you're just going to be dealing with web services. But if I also wanted to expose this same .NET component through another transport, then I'd have to have another mechanism over here, write a little bit more code, or in some cases a lot more code, to expose that same component. And to consume them, I'm going to be consuming them in entirely different ways. So what WCF does is it gives us a new way of easily exposing those components. I have my same .NET component up here, and instead of actually exposing it through the ASMX file, instead I define a service contract. And the service contract basically lets me specify attributes on my component that says, hey, this is what I'd like my component to look like to anybody that wants to consume it. I can then expose that through a particular host, in this case an HTTP host, and this HTTP host will understand that in order to expose this component, it must understand this contract and expose this contract to anybody that wants to use it. So then my HTTP client will go ahead and allow me to consume it through that, based on that service contract. Now, the difference between what we did previously and what we're doing now is that now, because we have this service contract that defines how this component should be exposed, we basically have abstracted out the protocols and the transports that we're going to be using, so that I can just go through here and add any of them that I want to at will beyond the service contract. Because the service contract tells us what we can expose, not the actual implementation of it. So now that I know what can be exposed, I can add on my TCP host, my ICP, which is my named pipe host, as well as an MSMQ. Now these are the four that are included out of the box, but this is a pluggable architecture, so you can add your own at will. And then any client that needs to communicate with my component through TCP can do that. This is synonymous with the old .NET remoting. Here's ICP client, which is if we're communicating via named pipes. And then lastly, an MSMQ client. Any MSMQ client can actually consume this the way they need. So let's take a look at one of these services in a little bit more detail. Every Windows Communication Foundation service is composed of at least 4 parts. The first one is the contract itself, and that's simply a class or an assembly that exposes or that contains the functionality that you would like to expose. The next 3 are what we call the ABCs. The ABCs, and I should have reordered this slide so that it was in order, but we have an address, we have a binding, and we have a contract. The contract actually defines the capabilities or what it is this service does. It's a bit like a type library if you're in the old COM days. The address is basically where the service is going to be hosted. What address do you want to use to access this service? And the binding actually defines the how. It's the how the service is going to be accessed. What protocols or bindings are you going to be using? Is this binary? Is it text? Now keep in mind that a single service can be exposed over multiple transports simultaneously, just like you saw in that previous graphic. So we might have multiple bindings and multiple addresses for the same contract and the same service. And I'll actually demonstrate that in the second set of demos. But let's start off with by taking a look at a simple WCF service here. Now, when I move to the next slide, it's going to move over to a view sharing demo, and my screen resolution is set to 1024 by 768. At 1024 by 768, you should be able to see my entire screen, if your resolution is that or higher, by pressing the F5 key on your keyboard. That will maximize your live meeting viewing so that you can actually see the entire thing. So I'm going to go ahead and move over to that now. And now you should see my desktop. And I have running on my desktop a copy of Microsoft Virtual PC 2004. And inside that I have Windows Server 2003 running. So what I'm going to do is I'm going to go ahead and launch Visual Studio and go ahead and ask it to create a new service for me. So we're going to create a new project. The project that we're going to create, actually I want to create a web service. Let me cancel out that dialog. File, new website. The website that we're going to create is a WinFX service. Now I actually have the WCF, the .NET 3.0 Framework SDK installed here, and that actually installs the WinFX service project type here. And I can go ahead and give it a name that I want to. We're going to go ahead and give this just a demo name. We'll just call this My Demo. And we can do this in C# or Visual Basic or J#. I'm just going to choose C#. It really doesn't make any difference. The code really isn't going to look that much difference between the two. When I run this, what it's going to do is it's going to create a service file for me, this service.svc file. The service.svc file, let me bring that up, is basically the equivalent of an ASMX file. It's the equivalent of a web page or the container page for a web service. Let me go ahead and expand these out. You'll see that the only difference between it is instead of being called a service or a web service or a page, we have an @service host directive. We have the same language, we have the same service and the code behind files that you would expect to see. In fact, if I wanted to, I could actually stick inline code in here, but that would kind of defeat the purpose of actually exposing this. So instead what we have is a code behind file, and the code behind file basically has references to the required components for this. In other words, it has the contract. Remember the C portion of this. We have the contract of our component that we want to expose, and in this case it also even contains the component that we're exposing. So here I have a class called MyService. This is the class that I'm going to be exposing, and it has two operations, my operation 1 and my operation 2, that actually take a string value in this case, and this one takes a data contract, which we'll talk about in a second. But we're going to take this string value and pass it into this method to actually process it. And basically what it's going to do is it's going to take whatever value you pass in and simply return that appended to hello colon. And then same thing happens in operation 2. So what we have here is that service contract, but you'll notice that I've actually defined the service contract attributes on an interface and not actually the component. If I wanted to, I could have added those to the component. But this allows me to better utilize object-oriented style development. In this case, what I can do is I can have multiple classes that all implement this interface, and they would all be exposed through this service contract. So the service contract attribute is basically applied to an interface to let the world know that we're going to be exposing anything that implements this interface as a service component. We then have another attribute called operation contract. An operation contract is an attribute that we would specify on each one of the methods that we would like to expose. The operation contract basically says, hey, I want to take this method and I want to expose that as my web service. So as my service. So if you think about this in web services terms, these are web methods, and this is the service action. This is the actual web service, and these are the web methods that we're exposing. Now, one additional feature that we see here is that down below here in the My Operation 2, we actually have a custom business object called a Data Contract 1, and that just happens to be a class that we have. This could have been any name. It could have been called customer for that matter. So here we have a public class that has some public properties. Here you can see my public string, first name and last name. And this is defined through a data contract. This is a complex business object, if you will, and this is how we expose that complex business object to anybody consuming this. So we have a data contract, and then each one of the members of that business object are exposed as what we call data members. So these attributes indicate to anybody consuming this that, hey, this is a business object. It's called a data contract 1 business object, and these are the members, the first name and the last name. Those are going to be exposed for anybody to consume that. And there you can see we can simply then refer to that parameter, that data type, if you will, inside the declaration of that. So we don't have to do anything in addition to that. Now, if I wanted to, I can just go ahead and run this page just like it is. What this will do is this will go ahead and, just like we did in the web services days, it will go ahead and launch Internet Explorer for me and navigate out to a page where I can test the service that I just created. Now, this looks a lot like a web service. In fact, when it comes up here, which will take just a second because it's launching the test server on my machine here. But when this comes up, you'll see it comes up with the same kind of page that we're used to seeing for our web services. We even have a link here where we can actually go and click on it and bring up the actual WSDL file that anybody consuming this web service or this particular service, not necessarily web service, but anybody consuming this service would actually use. So I'm going to go ahead and take advantage of that. I'm going to create a new project out here, and this project is going to consume that that service that we just created. So what I'm going to do is I'm going to simply create a Windows application, and let's just add this to the new project here. And we'll go ahead and drag out a button on there. We're not going to be really fancy on this particular application. Double click on that to get to the code behind that. Now, to consume this service that we just built, what I'm going to do first off is I'm going to add, let's go ahead and set that as a startup project. We're going to add a couple references. The first one that we're going to do is we're going to add a reference to the system.service model namespace, because we need to have the ability to consume those services, so our application has to know that it is actually going to be using that. So we're going to use system.service model. So I've added that reference. I'm also going to add a reference to this service that we just created. To do that, I'm just going to add a service reference, and we're going to browse out to the URI or the URL for this actual application. To do that, I guess I need to have this running. Let's view that in the browser. Go ahead and copy that URL and paste that into the references, service reference here. And we'll call this my first service. We'll go ahead and click OK. And what this is going to do when I add this reference is it's going to add a reference just like it was a web service to this new service that I just created. And it'll take just a second for the machine to catch back up with me here. While that's doing that, we'll see what it does behind the scenes. So I've added this service reference to this project. Now what it's done is it's added in the service references folder here, my first service, the map file. In addition to that, it also has the my first service proxy file, which is the actual proxy that's generated by the tool to actually allow me to call this. So back over in my form, what I'm going to do is I'm going to go ahead and change the name of the form to whatever the results are based on this service that we're calling. So we have a service called My First Service, and I have a proxy class that's generated inside there. So I'm going to create an instance of that proxy class. And now that I have my proxy, I've created an instance of this class. I'm going to go ahead and call that. So I'm just going to say this.text is equal to proxy dot, and then we have two operations, my operation 1 and my operation 2. So we'll just pass in my operation 1 hello world, and it's going to basically call into that class, call into this service, pass in this parameter, get the return value, and drop it into the text box. So if I go ahead and save this and run it again, We're now going to be running my new Windows Forms application that has the one button. If we move it into the center of the screen here and click the button, it's going to make the call out to the service, take the value that's returned back to it, and drop it in as the title of the application. And there you can see it says Hello World. So we made our call to our service just as if it was just like a web service call. Now, I'm going to go ahead and return back over to my slide deck. I've got one question in the queue. Let me take a look at that one real quick. Okay, Dan's question is, to what extent of WCF support is in CF in the first release? CF meaning the Compact Framework. And at this point, we haven't done any Compact Framework releases for WCF. I honestly don't know what the future plans are. I'm sure they are planning on doing some of that, but at this point, there isn't anything in there just yet. Okay, back over to our slide deck here. So, by the way, to do those demos, you can actually go out to msdn.com/Vista, I believe it is, or Microsoft.com/Vista, and go to the Developer Center. And from there, you can actually download the SDKs for WCF, or in fact any of the other .NET 3.0 platform stuff. Okay, so questions have come up as to which protocols to use, when, and why. So pretty much the rest of the day we're going to be talking about those protocols and how we can use them and what we can use them for. Now WCF actually supports many different protocols, but there's basically two types of protocols, text-based and binary. Text-based, meaning HTTP-based, supports standard ASMX style services as well as web services enhancements. So you just saw the ASMX style service I just built. It wasn't really a web service from the point of view like you built the old web services, but it looked the same. It acted the same. Now the nice thing about what I just did is I can use that same model to expose it not through just web services, but through TCP, through name pipes, as well as MSMQ, and any others that are added that rely on that utilize the correct protocols, if you will, or the correct base classes. So text is great for web services style stuff that you're used to. Binary is great for doing things like TCP, name pipes, and MSMQ. Now TCP is the protocol that you would use if you were using .NET remoting in the past, or if you need to have high-speed machine-to-machine communications. So you need to talk from one machine to another machine, but you'd like it to be as fast as possible. You're probably going to use TCP binding. ICP, or named pipes, is an intra-process communication. So what that means is that if you have two different processes running in the same machine and you would like them to talk to each other. Now it's not going to go outside the machine boundaries, but as long as it's within the machine, you can use named pipes to actually do that communication. And that's the net name pipe binding. The last one is the MSMQ. So if you need to have delayed messaging scenario, so I send a message and I need it to be processed when we can get time, for example. Let's say I have a high-speed system communicating with a slow-speed system or slow-to-process system. Well, in that case, I might want to queue up my messages. So I have a burst of messages that go into a queue, and then when the back-end process is able to deal with them, it can deal with them and pop them off that stack one at a time. So in that scenario, we'd probably use the MSMQ binding. So what I'm going to do now is I'm actually going to go back into a demo here, and we're going to go ahead and drill in and take a look at a few of the different transports that are available and how we can actually use them and the differences to consume them. So I see a few questions in the queue, and I will get to those as soon as I get back from this next demo here. I'm going to go ahead and open up a project that already is out there. I have a project starter site here. This will just jumpstart us so we don't have to develop everything from scratch. So what I have is a solution. that has basically 3 projects in it. I have a demo library, and this is very similar to the class that I just exposed earlier. It's simply a demo library that has a single class in it. Now, believe it or not, I'm not going to show you what's in this class because you don't need to know. The whole idea behind this model is that we don't care about the implementation details. We just care about how it's actually done and how we make the calls. And that's actually handled through our contract that we set up. So here we can see I have an interface called iDemoClass, and we can see that my actual business object implements that interface. So we can assume that we have a service contract that's exposing 2 methods, a hello world method and an add numbers method. The hello world returns a string, but it takes no parameters. The add numbers takes 2 parameters and it returns takes 2 integers and it returns an integer. So hopefully within their implementation inside here, they've done some error correction or handling, 2 plus 2 equals 5 for very large numbers of 2, right? Or very large values of 2. So that kind of thing here. So we just have to make sure that or assume that they've done something correctly here because they've actually exposed this to an operation contract saying, hey, this is one of the methods that I'm going to expose to my consumers. Now what's interesting about this is there might be 500 other methods inside this class, but we don't care about them. We only care about the 2 methods that are exposed. And we can pretty much see what's going on here. So we can, being developers, can read this and pretty much understand how we're going to consume this service. Now to consume that service, I have a host file here called the simple WCF host, and you can see it's a pretty complex application. As a matter of fact, if I bring this up here, you'll see all of the code that I've written to expose everything. In fact, there's absolutely nothing in here right now. I haven't written any of the code required to actually make this work just yet. But we are going to do that in just a couple more steps. The last application that I have in here is actually a client that I've built to actually consume the services that this simple WCF host is exposing. Now it's important to understand that I'm going to be exposing these services through various protocols. And I can host those services in any type of application that I want to. So you saw in the first demo, I actually hosted it in IIS. I had a service implemented that was very similar to a web service, and in fact actually was hosted in a web server. But it doesn't necessarily have to be a web server. In fact, a lot of scenarios that developers would build an NT service, or a Windows service that would run in the background exposing the services. But I'm just going to show you how to do it through a simple Windows form. So I have my main form class here, and you can see it has no UI pretty much, just the form, but that's just going to be a container for it. And then the client itself is another Windows form that has a go button and a field here to actually allow me to display the results when here you can see I'm going to implement first off a name pipe service for my client. So let's go ahead and start coding this. What I'm going to do is go into the actual code for the code behind and go ahead and start adding some code to this. The first thing that I need for services is to make sure I have my correct references set up. The first reference that I need is, again, that system.services model. And there it is. So I've added that reference. Now that actually adds a reference to from the system.namespace. But because this component is actually going to be exposing this demo library, I also need to have a reference for that. So I'm going to go ahead and choose my projects and expose my demo library through that. Now that I have that exposed, those references set, I can go ahead and start doing some code. So the first thing that I need to do is I need to actually have a variable or an object to hold the actual host object that I'm going to be dealing with. So to do that, I'm going to set up a couple of shortcuts here to the system.service model. Now I have that. Now we'll go ahead and in my class go ahead and define a host object for us. This is going to be a service host. And we'll just call it host, and we'll set it to nothing to begin with. So I have an object that's actually a service host that doesn't do anything at this point. But when this form loads, or when the when the form loads, we can go ahead and do it there. We'll go ahead and we'll start initializing everything. Now the first thing that I need, remember we need our A Let me do that. We'll just do it this way. Our B, and it's, type this in correctly, Bill, and our C. So we have our address. These are the ABCs of services. We have our binding, and then we have our contract. And what we'll do is we'll go ahead and set each one of these up as we go along through here. So the address, to begin with, what I'm going to do is just simply create a URI object. And the URI, we'll just call this my base pipe address. And we'll go ahead and spin up a new URI. Now the URI actually takes just a text parameter here, and this is basically going to be a name that I'm going to give it. A URI is a unique identifier for a particular resource, not necessarily a valid URL, but in this case it's going to be. So we'll have our local host, and we'll call this my test service. So now I have my URI set up, and that's my address that I'm going to be using. Now that I have that address, what I need to do is I need to create an instance of this host and go ahead and add that to that. So we'll take our host object here, and we'll say it's a new service host. Now, this is a very important parameter that we're going to be passing in here. This is basically the class that we're going to be using or to be exposing. So we have this demo class object up here, and we're going to be exposing this class right here as our service. So to do that, oops, let me pop back over to my correct view here. What I'm going to do is I'm actually going to say this is a type of this demo class. Now I'm saying type of because I'm having it create a new instance for every call that comes in. If I wanted to, for example, if you're used to .NET remoting, and this is a question that came up before, if you're used to .NET remoting, and in .NET remoting you had the ability to control how you actually created a component remotely. So it could be a singleton object. In other words, everybody coming in goes into the same object, or it could be a type where everybody coming in would get their own individual object. And what I've done with this is because I'm using a type of demo class, for every call that comes in, they're going to get their own unique one. If I wanted to, I could have said, let's see, demo class C equals new demo class. Now I have my new demo class, and instead I could just pass in the C object here. And because I'm passing in the singleton reference to it, all the calls coming in would actually go to this one instance that I just created. And that's what we call a singleton. So that's how I can control my instantiation of those. So you have an option there. That's we'll leave that up to you how you want to implement that. Now it can get more sophisticated than that, because when you pass in the singleton, you can also pass in a singleton to a component that's managed through the enterprise library. So you can deal with transactions and multiple kinds of complex issues there. The second parameter is actually the address that we're going to be passing in, or we're going to be referencing, and that's simply by passing in this base pipe. This URI that I just passed in, we'll just set that up. So there I've defined the address. The next thing that I want to do is I want to define the binding. And because we're using named pipes, I'm going to go ahead and use the net named pipe binding object here, and we'll just call this my pipe binding. So now I have my binding object. Now what I need to do is go ahead and specify the contract that we're going to be using for this. To do that, I'm going to take my host object, and I'm actually going to add a service endpoint. Now the service endpoint is actually going to bring all these items together. So the first thing that we're going to do is the contract. Now if you remember before, up here at the service host, I actually passed in the type of the demo class. And the type of the demo class, let me tell this system that, hey, what we're going to be doing is we're going to be passing in, or every time somebody makes a call to this, I want them to get a new instance of this class. So this is dealing with the actual class itself. But on our class, we actually have an interface that exposes our service contract. So what I'm going to do is I'm going to pass in the contract. That's this class right here. So I'm just going to take the iDemo class. So anything that implements that is going to be passed in. The next thing that we're going to be passing in is the binding, which is the pipe binding that I just created. And then the last thing is the address, which is going to be that base pipe address that I created earlier. So now I have my address defined, I have my binding defined, and I have my contract defined. And this allows me to tie everything together. Once I have it all tied together, I can go ahead and tell this service to go ahead and open up or to start. So it will then start listening on this service, and any calls that come into this via named pipes are going to get passed into this class here, exposing the components through this contract right here. And one last thing I'm going to do just to clean this up a little bit is I'm going to say open host dot, oops, get the right close. So when this form actually exits out, we'll be nice and clean up after ourselves and shut down. So I now have my service component exposed through this little Windows form. And if I go ahead and run this, let me make sure I set up the project right. Set that as the startup project and go ahead and run that. We will now have a class exposed through a service reference via named pipes. Oops. And I have a little bug in there. Must have typed in something wrong. I did type in something wrong. How about if I put the colon in there correctly? That always helps. And I'm sure some of you caught that out there and probably even commented on it. Again, it's a URI, has to be validly formatted. But there you can see my service is now running. And now to prove that it's running, what I'm going to go ahead and do is I'm going to add a reference to that. So I'm going to add a reference to that service that I just created, and that's going to be a net pipe localhost test service. And we'll call this my net name pipe service. Go ahead and click OK. And because that component is running, it's now exposing that service. I should be able to go through here and consume that service by adding the reference to it. Adding the reference, you can see added the code here for it. If I go back to the main form, I should now be able to go ahead and simply create an instance of that class and name pipe service. Create an instance of the proxy just like I did before. And then go ahead and say that named pipe output text is equal to the proxy dot hello world. So basically what I'm doing is when the user clicks on the button, we'll go ahead and create an instance of the proxy class and call the method hello world. I'll go ahead and save that. We'll right mouse click on the test client and choose debug start new instance, because remember Visual Studio is already running the host application down here. So I'm going to go ahead and launch that. We have our service running. We should have our client pop up here. There's our client. I can now click the go, and it'll make the call to the name pipes, and that service will return the hello world text that other method is obviously exposing, or that other class is obviously exposing. Now, to take this a step further, now we know how to expose one service, but I said earlier we can actually expose multiples. And we've got a couple different ways of doing this. I could, if I wanted to, expose these through various means, through configuration files, but I'm just going to go ahead and expose these through some more code here. So I'm going to expose this, basically change this code here to add a few more URIs. For example, let's do a TCP pipe address. Let's change that to port 8000 just to show you can do it on different ports. And in fact, I'm going to give it the same application name. We'll go ahead and do one more, one that people are very familiar with. This is going to be http:// localhost, and we'll put that one on 8080. So now I've added two more addresses that I'm going to expose this class through. And if I wanted to, I could have done this ahead of time. But now what I'm going to do is I'm going to take those addresses and add them to the service host as listeners. So to do that, I'm just going to simply add a TCP address and an HTTP address. Now you'll notice that I was able to add those at the end of this parameter. Because the service host method actually has a parameter array as the last parameter, this is one of the new features of C#. VB, it's like the old parameter array, but that functionality is now exposed to C# developers. So now that I have that, I need to go ahead and create some bindings for each one of the new protocols. So the net TCP binding, we'll call this the TCP binding. New. And we have another one for web services. This is WS HTTP binding. Now, the question comes up there is, what other kinds of bindings can I do? Can I do secure and things like that? Yes, there's actually quite a few of them. So here's WS HTTP security. We even have dual security modes if you need to use that. So we pretty much have all of the WS security models covered when we're doing the WS web services stuff. So now I have 3 bindings. I have 3 addresses. It's time to go ahead and spin up a couple more endpoints here. Add a service endpoint for the type of iDemo class for TCP binding. And we'll call this our TCP address. And the last one is host HTTP binding, spelled correctly. So now I have my service exposed through 3 different protocols, name pipes, TCP, and HTTP. And we can go ahead and, again, run our host. Let's just go ahead and run it that way. If everything compiles right, we can ship it, right? Okay, it compiled and it's running. So now what I can do is go ahead and back to my test client and add a couple more service references. This reference is going to be the TCP version, so net TCP. Localhost, again, we changed the port on this one, so we'll call this our test service on port 80,000. So this is the TCP service. And that'll take just a second to run that. And we'll see that that adds that service as well. And then the last one, we'll go ahead and add another one to the HTTP version of it. And I think we put that on port 8080. We'll call that the HTTP service. And again, that'll add another proxy to allow us to use that. And there you can see the proxies for all 3 of them. The TCP and the HTTP services are out there. Now, to consume that in our code, we'll go ahead and bring up our main form. And what I want to do is I want to go ahead and take this main form and expand it out and add 2 more buttons for each one of the 2 protocols. So to save time, I did that ahead of time. That allows us to go back there and do this much more quickly. So I now have pretty much the same code that I used before. I'm just going to duplicate it for both the TCP and the HTTP services. So TCP service, demo proxy class, we'll call it again proxy equals new. And then same thing down here, we have the HTTP service. Now, some of you might already be aware that I'm actually hard coding this. I don't necessarily have to hard code this. If I wanted to, I could have just gone in and on the app.config file, right mouse clicked on it and chose Edit WCF Configuration. And what this does is it brings up a nice little configuration tool that will allow me to change the configuration properties of these bindings. But I wanted to show you in code that we are doing the exact same thing throughout the entire thing. So here I can just basically take this code here, copy that, paste it there, and paste it there, and change these to TCP output and HTTP. Oops, let's get this right. HTTP. I can't remember what the name of that box is. It's this text box here. HTTP service output. There we go. So there we have the exact same code. I'm making the call the exact same way in all three instances. Again, our service is still running, so I should be able to go right down here, choose Debug, Start New Instance of our client. Our client now has 3 different buttons. They're all calling the same service, but they're doing it through 3 entirely different protocols, 3 entirely different mechanisms. But from an end user's point of view, the experience is the same. From the developer's point of view, the experience is the same. So here you can see how we have a unified approach to actually building these services. So I have a few questions in the queue here. Let me bring up the queue manager. So is it, let's see, Terry's question, is it using text over HTTP binding and binary over the TCP and pipe bindings? Yes, it is using a text over the HTTP binding, and that depends on the formatter that you're actually using, but the default formatter is going to be using text over HTTP, and it's going to be using binary over TCP. Now you could just as easily do text over TCP, but that's just an option. I got a question about what is the performance difference compared to remoting? Actually, you shouldn't see any performance differences. WCF is, in a word, fast. So I doubt that you would see any differences in performance-wise. Remember, we're using basically the same protocols. You would just use a, it's just that you're utilizing a new model, if you will. You're doing the same thing. Does WCF support HTTP features such as compression, keep alive, and basic authentication? WCF is going to utilize whatever the protocol standards outline. This is, again, the compression and things like that are going to be however it's implemented on it. We don't really care how it is. Again, WCF is about the message and not the actual protocols and things like that. We're going to leave those details to the actual providers that are provided. So if the standards require that those are in there or have those options, I'm sure that's available. I know basic authentication, for example, is one of them that is there. Let's see. Okay, let me get back to some of these in a little bit here. Let me pop back over because we got just a few minutes here, and I want to talk about this because it happens to be one of the questions in the queue. Transports. When to use binary, when to use text. It's a pretty simple grid. Basically, we have the text advantages and the binary advantages, and then the disadvantages for each one of them. The text advantages, very interoperable. We are using Web Services standards, so the WSI Consortium set up a group of standards, and we are using them to the T. So interoperability is guaranteed in this scenario. We also support any existing Web Services standards, so if you have legacy systems already out there developed with this, we already support that. Text is easily firewall friendly because it's just port 80. Pretty much any system has port 80 open, allows to get through there. The disadvantages of text is that it's slow. Because we have to have formatters to deal with processing, for example, we take our message and we base64 encode it. It takes a little bit of work to do that. And that happens to be a disadvantage in high volume scenarios. Now, binary has the advantage of performance. It offsets that slowness of text, if you will. Now, I do want to point out that when we say text is slow, it is slow, but it's not that slow because most of these systems are designed around the high performance mechanisms so that they kind of overcome those issues. But still, binary, because we don't have to deal with the fancy formatting, we gain performance over the text-based scenarios. It also allows us to work with native types pretty easy because both sides are typically going to be aware of the types at each end. We don't have to do any conversions to some lower common denominator, if you will. So that helps us out as well. Now, binary has a big disadvantage with interop. Interop is not something that you're probably going to get between disparate systems simply because the back-end systems required a lot of massaging to make sure that they're the same. if they are different systems. So that you're going to be doing a lot of work ensuring the integrity of the data, if you will, or the objects. So typically that's going to limit you to WCF to WCF scenarios. It is possible to do WCF to other types of systems. It's just going to require a whole lot of work on your part. So I just wanted to show you some performance considerations as we wrap this up. We just got a few minutes here, and so we'll go through this pretty quickly here. Let me bring up the code here, and just go ahead and I'm going to wrap a little bit of code around this. I'm going to go ahead and set up a little system.diagnostics, and we'll set up we'll use the stopwatch to actually get some performance. So what I've done is I've just created a little stopwatch timer here, and I'm going to create two methods here. The first one is going to be a start timer, and in start timer we'll have a watch.reset, and then we'll have a watch.start. And what that's going to do is that's going to basically allow me to, in my code here, start the timer in each one of these methods. And we'll just do the first one and the last one just for performance, just to speed up a little bit here. And then we'll have another one called stop timer. And in fact, what I'll do is, we'll go ahead and do stop timer. And we'll say, in the stop timer, we'll just say the watch.stop. And then we'll take the results of that. So this .text equals watch.elapsed time, and then we'll just go grab the total seconds and convert that to a string. And we'll just drop that in the title of the form so we can see the difference in performance there. Now what I need to do is I need to go ahead and put a little loop around each one of these lines here to slow them down, if you will, because otherwise it's going to happen extremely quickly. So what I'll do is I'll just do a little counter here. And we'll do just 500 iterations. And then at the end we'll stop the timer. There we go. And we'll copy that to there. And then we'll stop the timer there. Okay, so what I'm doing is I'm doing the exact same code in both button 1 and button 3, which is, the first one is the name pipe, the second one is the HTTP. I could have done to the TCP, but you'll find that the name pipes and the TCPs, because they're on the same machine, are pretty much going to go at the same speed here. I have my service still running. I'm going to go ahead and rerun my client now. And when I stop the timer, what's going to happen is it's going to take the value from the stopwatch and it's going to display that up here where it says Simple WCF Client. So if I click on Go, it's going to iterate through calling this 500 times. And there you can see it took 4.96 seconds to do the name pipes 500 times. To do the same service, which is the text-based service 500 times, we're going to see that it's going to take a little bit longer. Because it has to deal with the intricacies of the actual the calls themselves, processing of the text messages and things like that, it's typically going to take you on the order of 3 to 5 times longer. So we should see there, here it took 17.53 seconds. And to be fair, if we hit it again, it should speed it up a little bit because it had to spin up the instance of the protocols and things like that. But it's not going to be that big of a difference. So we're still waiting. There we go, 16.99. So it really wasn't that big of a difference. And if I would have did the TCP service, we would have found that the TCP service was just going to be a tick or so slower than the name pipe service. It would have been in the 5-second range as well, maybe 5.2 seconds. It's still going to be faster than the HTTP service. And that's pretty much an apples-to-apples comparison when you do that. You know, I'm iterating through them 500 times. I'm giving them time to spin up the proxies. I'm doing the same, you know, start and stop process. So we can see there is a little bit of overhead when it comes to doing those TCP-based or HTTP-based text-based calls. So a quick little summary here. By the way, there are questions in the queue. I'll get back to those while you guys are answering the questions there. We covered what the .NET Framework 3.0 is, formerly known as WinFX. We looked at services orientation. We looked at the actual services and how we implement services and transports. And then the last thing, we wrapped it up with a little bit of performance statistics there. Here's a couple places that you can go to actually learn more. The WinFX Technologies off the MSDN site has some great resources for getting that. Also, you can go to Microsoft.com/Vista, and then over on the left-hand side, choose for developers, and you'll be able to get to a lot more information as well. At this point, I'm going to go ahead and turn it back over to Tracy so she can get you into the survey, and I'll take a look at the questions in the queue.
Excellent. Thanks, William. Remember, for more information, everyone can print a PDF of today's session. To do that, just go to the File menu in your upper navigation bar. We will be getting into the questions and answers here shortly, so go ahead and feel free to submit your questions now. Also, I'm going to be posting a survey here in just a minute. If you could please take a moment to fill it out before you log off. We do appreciate your feedback. And for any upcoming and previously recorded webcasts, you can go to Microsoft.com/webcast. This webcast will be available for download in about 24 hours. Also, if you have any webcast content ideas, if there's something out there you'd like to see and haven't yet, we'd love to hear from you. You'll just want to take note of this link here in the middle of the screen. And for anybody who's interested in getting a free 14-day trial of Microsoft Office Live Meeting, you'll want to go to Microsoft.com/presentlive. And here's the survey from our session today. Please follow the links provided to complete today's webcast evaluation. And William, it does look like we have a few questions waiting there in the queue for you if you want to take a look at those.
Okay. Dan is asking, he's actually continuing on his Compact Framework question. He says, if we use WCF on the server side, can we use Compact Framework to make basic web service calls? And would those calls be compatible with the WCF service if we use HTTP transport and text encoding? Dan, you hit the nail right on the head. That is exactly what you do with them. So that is, yes, you can use those. Jose is asking, I understand you can do web services with directly from SQL Server 2005, and he's wondering how WCF SOA model fits into the SQL model. Well, actually, in that scenario, SQL Server becomes a part of your services model. It is exposing those services as WSE or WSI compliant web services. So it can fit in and consume, not only can it consume your text-based web services, it can also emit them as well. Raphael's asking if I could explain the dual WS-HTTP binding that I mentioned earlier, and when would I use it as opposed to the regular WS-HTTP binding? That's actually a really good question. Typically when you see a binding like that, what you're seeing is in the WS-HTTP binding, that is a call, that's a one-way call. I'm making a call to a service. Okay. With the WS-HTTP dual binding, that's actually a duplex call. So when I make the call to the service, it has the ability to call me back. So that's what we mean by that. It's a duplex binding. We get two-way communications. I've got a question about what software tools are needed for WCF, like Visual Studio 2005 and Framework SDK. We actually have that. If you go out to Microsoft.com/Vista and go to the developer section out there, you'll see all the requirements for that. That's actually changing on a daily basis because of the later builds, if you will. So in order to get the latest information, I highly recommend you go out there. But it'll tell you everything that you need. Now, it is included. WCF is a pillar of the .NET 3.0 framework. So any machine that has the 3.0 framework on it should be able to do a lot of this WCF stuff. Specifically Windows XP and Windows Server 2003, as well as Windows Vista, along with the other pillars in the .NET 3.0 framework, WPF, Windows Presentation Foundation, which is only going to be limited to, all of it will be in Vista, and only subsets of it will be in the other operating systems. And then InfoCard as well as Workflow Foundation. Is WCF built on top of .NET remotely, or is it a completely new stack? The WCF architecture looks very familiar and a question just popped away, but before I could read it all, it is an entirely new architecture. It's built from the ground up. We took a lot of the learnings from .NET remoting and web services and all that, but we, it's pretty much a complete rewrite of it. Okay, let's see. Okay, Raphael, I don't know what that question is. He's actually trying to install it right now. If you could, Raphael, just go out to my blog and ping me, ask a question out there, and I'll see what I can do to help you with that. I don't know what that is asking for right there. Again, the .NET 3.0 framework is, again, it's still beta, so I don't recommend you put it on your production machines. It is actually pretty stable, but there are some issues with it. And he's actually bringing up an issue during the installation that's having issues with the 2.0 framework that he has already installed on there. And that's all the questions I have actually in the queue right now. So I want to thank everybody for watching today's session. And again, keep up to date on what we're doing, msdnevents.com. You can go out and see what we're doing live. I'm showing about 7 minutes after the hour here, so I guess we'll go ahead and turn it back over to Tracy and let her wrap up.
Excellent, thank you. Well, I do want to extend a special thank you to William for presenting today. And I'd also like to thank the audience for attending today's MSDN webcast. So ladies and gentlemen, this does conclude today's session. The audience may now disconnect from the audio portion of this presentation.